We are closing in on the end of these problems. The angle of elevation to the top of a tree from a point 40 meters away is 40 degrees. And I have no idea why I didn't draw you a triangle here. I'm sorry, but you can draw one. It has to be a right triangle. And we want the elevation to be 40 degrees. This is a tree. This is the top of a tree. And 40 meters away. This is a little confusing. Are we calling that hypotenuse? Let's say that 40 meters is on the ground. Let's clarify this one because that could be a little misleading. But let's put it right down here. I think that's what they meant to say. What is the height of the tree? Don't care about hypotenuse as long as I said on the ground. Theta, I do care about. The tree is opposite, and the 40 meters is adjacent. So I'm going to use the tangent ratio. If you get one of these problems and you're not sure, like that on the ground part, ask your instructor because it matters. You'll get a different answer if you do it the other way. So opposite is our tree. Adjacent is our 40. You would use a different ratio if you made it be the hypotenuse because tangent doesn't use hypotenuse. So the tree is about 40 times the tangent of 40. So it is approximately, let's round to hundreds on this one. Hundredths, excuse me, not hundreds. Approximately 33.56. Again, that's a very tall tree if we're talking meters. I think feet would have been a much more reasonable unit, but the problem used meter. So, a 30-meter tall tree. I'm going to go this way this time just to show you it does not matter. What matters is that you have a right angle. And this time we know the height of the tree. That's over 90 feet. That's a tall tree. That forms a 45-degree angle with the ground. What am I missing? A 30-meter tall tree casts a shadow. That's what I'm missing. That forms a 45-degree angle with the ground. How long is the shadow? So we want to know this distance. And the sun would be shining this way. So we know the height of the tree is 30. That's opposite. We want to know adjacent. That's the shadow. And we know theta is 45. So yet again, we're using TOA. So the tan of 45 is opposite over adjacent. I don't like S as a variable. It looks too much like a 5. So be sure you know that's S for shadow. You can use any letter you want to there. But we are going to have to divide tan 45 out. So S equals 30 divided by the tan of 45. And we're rounding to hundredths. I don't think we have to round this one, do we? About 30 meters. Okay, the wave height. This is an interesting problem. I'm sure I have seen one of these, but not in a while. So, a ship is sailing in the ocean, and the height of a wave. So let's put the ship out here. Here's the ship, and here comes the wave. The height of the wave is measured to be 15 meters. That is a big wave. I'm glad I'm not on that ship. That's over 30 feet. If the angle of elevation from the ship to the crest, a crest of a wave is the top part, is 20 degrees, how far is the crest of the wave from the ship? So I want to look at this distance. We're looking for hypotenuse. And before I go any further, let me make sure that you understand about a wave. So let me draw, I'm going to switch colors. This is not related to the math itself, but it is related to the concept that we're seeing here. So if this is the wave that's coming up through the ocean, this point right there is called the crest. This point is called a trough. And I'm going into this because with electricity, you may get some wave theory. Okay? So the crest of the wave is the equivalent to its height. It's this distance right in here. Well, the iPad has different ideas. There is a right triangle. Okay, so the crest is actually the peak of the wave. That's this 15 meters. And I tell you what, I'm going to replace, oh, I can't. Dadgummit, let me try something. Because this picture, for some people, this is not a problem at all. And for some students, this can be really problematic because you don't think of a wave as a triangle. I also want you to understand a little bit about wave theory. So let's bring this bad boy right over here. This is our picture. Well, I don't know that it's going to allow me to do that. It's not. It's putting that white line in there. So let me move it back over here. So here's your right angle. That sets up opposite. This is still hypotenuse. And instead of trough, we've got our boat out there. So let me just put that here too. Okay, so they want us to find, if this is 20 degrees, they want us to find the distance, the hypotenuse. So we want to know this distance. We know the height of the wave, and we know theta. So we're going to use sine because hypotenuse is involved. The sine of 20 is equal to opposite over hypotenuse. So 15 divided by the sine of 20 will give us that hypotenuse distance. And it is going to be about 43.86 meters. So that boat is a good distance away from the crest of that wave. Still too close for my comfort. It's over 120 meters or 120 feet away. But that's still close for me. All right, last one. A wind turbine is tilted at an angle of 25 degrees to the ground. If the height of the turbine is 75 meters, what is the distance from the top of the turbine to the point where the tip of the blade touches the ground? So we want to know this distance. So we want to know hypotenuse. We do know opposite, and we do know theta. So hypotenuse is involved, and so is opposite. That is sine. So the sine of 25 is opposite over hypotenuse. So let's multiply both sides by the distance of the hypotenuse. And then divide out sine 25. So that distance is going to be approximately 75 divided by the sine of 25. I know it has to be greater than 75 because hypotenuse is the longest side. And it is about 177.47 meters. And that's massive.